Here we have another trigonometry equation dealing with multiple angle. We have sine of 2 theta here and sine of 4 theta there. Somehow we have to write that in terms of only one type of multiple angle. So we will have to rewrite the sine of 4 theta. Sine of 4 theta, we can write sine of 2 times 2 theta. And the double angle give us 2 sine 2 theta cosine of 2 theta. And that's the only formula we have. Of course, that will substitute in sine of 4 theta. So we will have sine of 2 theta. We usually don't need the parentheses for that. Minus 2 sine 2 theta cosine 2 theta. Equal to 0. Now both of them have sine of 2 theta in common. So I will factor it out. Then we will have 1 minus 2 cosine of 2 theta equal to 0. Again, we have a product equal to 0. So one of the factor must be 0. So if we have sine of 2 theta equal to 0, then all we have 1 minus 2 cosine 2 theta equal to 0. This will give us cosine of 2 theta equal to 1/2. Right. Now we just solve the trigonometry equation, both of them. This is a little more complicated because we have the multiple of an angle. So first, sine of anything is associated to the y values. The y values equal to 0 must be here or here. However, we have to write the answer in terms of coterminal angles. So either it's going to be 0 plus 2n pi we should write 2 theta because that is the whole angle of that function. Or we have 2 theta equal to pi plus 2n pi. And we're going to work both equations in tandem. If we divide everything by 2, the first part we have theta equal to, divide by 2 we have theta, divide by 2 we still have 0, divide by 2 we have n pi. So that's one of them. The second part we have theta, if we divide by 2, pi over 2 plus n pi. Right. Now we choose some values for n. Now if we let n equal to 0, theta will be equal to 0, the first one. Theta here will equal to pi over 2. Both of them between 0 and 2 pi, so it is good. Then we choose n equal to 1. If n equal to 1, put 1 here, we have theta equal to pi, which is good because that's still between 0 and 2 pi. And then if we choose n equal to 1, here we have pi over 2 plus pi, which is 3 pi over 2. Then if we choose n equal to 2, that will give us 2 pi which is not in that domain, so that doesn't work. And then that plus 2 pi, that also bigger than 2 pi, so that doesn't work. So those are all the solutions we have for that part. There are 4 of them on this side. Now we go to the other side. Cosine is equal to cosine of an angle equivalent to the x values. The x values of 1/2 will be right here. So associated to that we have two angles. One is here, which is pi over 2. I mean pi over 3. Or we can go all the way here. Give us, if this is pi over 3, then we have minus pi over 3, and add 2 pi to it, we have 5 pi over 3. So we have two answers here. 2 theta equal to pi over 3. Just write like this one. 2 theta equal to pi over 3 plus 2n pi. The 2n pi is the period. 2 pi is the period of cosine or sine. So we can have the coterminal or period more than just the answer itself. So have 2 like that. I just copy it, but right. Now we divide everything by 2. The pi over 6 plus n pi 5 pi over 6 plus n pi. And then we choose some values for n. At n equal to 0. N equal to 0, we have pi over 3, pi over 6. Just like theta equal to pi over 6. And on that side, we have 5 pi over 6. If n equal to 0. Now n equal to 1. We have pi over 6 plus 1 pi. So that would be 7 pi over 6. Still between 0 and 2 pi. Still between 0 and 2 pi. And then on that side, we have 5 pi over 6 plus pi is 11 pi over 6. And then when we choose n equal to 2, we don't need to do that, but when we have 2 here, that will be more than 2 pi. And here, the whole thing is more than 2 pi. So it's not going to work if n is bigger than 2. So we have the solution, those 4 solutions. And then this 4, 2 more here. And then actually 2 more here. That should be 8 answer. Like that. So we just rewrite the sine of 4 theta using double angle of sine, and then we factor. Each factor must at least one factor must be 0, and we let that equal to 0, and we solve for it. When we have the multiple angle equal to something, at the end we can divide back. We just have the angle by itself, the theta by itself, and then we solve for that. Make sure we have to choose some values for n, so that the answer will be between 0 and 2 pi. if we choose n too big, it will not be within 0 and 2 pi. And that is how we do that problem.